If you're into Hollywood and action movies, you might recognize this guy. Who is this? Is it Dwayne Johnson or is it The Rock? It's both, isn't it? Dwayne Johnson and The Rock are just different ways of naming the same person. That's kind of how it is with equivalent fractions. Same value, different numbers. Today we're going to look at how equivalent fractions can be made and why they're important to learn. Let's go. Welcome to Grip EDU with Mr. D. I am Mr. D, and thanks for joining me today. We're going to be looking at equivalent fractions today. So first, what's an equivalent fraction? Well, an equivalent fraction is a fraction that represents the same amount but uses different numbers. Think of it like this. Let's look at the fraction 1/2. Now let's look at the fraction 4/8. I've used totally different numbers, and yet these fractions are the exact same amount. Equivalent just means equal. So an equivalent fraction is a fraction that is equal to the original fraction, but uses different numbers. Now, there's a way that you can create these correctly. You can't just use any numbers and say that they're equivalent. Let's look back at the fraction 1/2. If you're taking notes, be sure to write this down. You can create equivalent fractions by multiplying or dividing the numerator and the denominator by the same number. For instance, with this fraction, if I multiply both the numerator and the denominator by 2, I'll get 2/4. And as you can see, that's the same amount as 1/2. I have different numbers now, but the value of the fraction hasn't changed. Or perhaps I multiplied the numerator and denominator each by 6. That would make 6/12. Once again, I have different numbers, but the value is still the same. As long as I multiply the numerator and denominator by the same whole number, I'll create an equivalent fraction. You could multiply both sides of the fraction by 2 or 3 or 13 or 149, whatever you want, and you'll create an equivalent fraction. So I can make equivalent fractions by multiplying the numerator and denominator by the same number. However, I can also make an equivalent fraction if I divide the numerator and denominator by the same number. For instance, suppose I have the fraction 6/10. What's a number that goes into both 6 and 10? What could I divide each of them by? How about 2? If I divided each number by 2, I'd get 3/5. And look, that's the same amount. The only tricky part with using division is you need to make sure that both numbers can be divided by that number perfectly. I couldn't take 6/10 and divide each side by 5. I can divide 10 by 5, but not 6. There'd be a remainder, and I can't have remainders when I'm using equivalent fractions. Try this one. Maybe I have something else like 8/16. What's a number that I could divide both 8 and 16 by? There's a couple, right? 8 and 16 are divisible by 1, 2, 4, and even 8. So let's go ahead and divide them both by 8. If I do that, I'll get an equivalent fraction of 1/2, and look, that's the same amount. The only whole number you wouldn't want to divide or multiply your fraction by would be 1. Can you see why? Because if I multiply or divide by 1, it won't change the numbers at all. All right, let's review. To make an equivalent fraction, you can what? Multiply or divide the numerator and denominator by the same number. Well, it's important because creating equivalent fractions is necessary for adding and subtracting fractions as well as simplifying. So this is a super important skill as you get going on your fraction work. Let's take a look at a few practice problems on the whiteboard. Grab your paper and pencil and let's get to it. All right, to start out, we're being asked to write 2 equivalent fractions for the fractions that are given. Watch how easy this is. Let's go ahead and write the original number, and then we can create equivalent fractions. First, 3/4. Remember, to create an equivalent fraction, I can multiply or divide both parts of the fraction by the same number. Let's use multiplication. Let's multiply the numerator and denominator of each by 3. 3 times 3 is 9, and 4 times 3 is 12. So that's an equivalent fraction. Now, why did I choose 3? No particular reason, I just wanted to pick something simple. For our next equivalent fraction, let's do the same thing as before, but this time let's multiply them both by 5. 3 times 5 is 15, and 4 times 5 is 20. So those are two equivalent fractions. If you're wondering why I didn't use division, it's because I can't divide 3 and 4 by the same number other than 1. For the next question, we have to fill in a missing number. This skill is huge for adding and subtracting fractions. You're going to be doing a lot of this type of thing. Okay, so we have a missing number to figure out. We know that 2/3 is equal to something over 12, but what could it be? Let's remember what we're learning today. You can make an equivalent fraction if you multiply or divide the numerator and denominator by the same number. Since I'm shown both bottom numbers, I'm going to focus on those. Now, if I multiply, I get a bigger number. If I divide, I get smaller numbers. So how do you think we get from 3 to 12? Multiply, right? Multiply by what? 4. So I'm going to write a little times 4 here. Now, since I have to multiply the numerator and denominator by the same number, if I multiply the bottom by 4, then I need to multiply the top by 4. And 2 times 4 is 8. So that means the equivalent fraction they're looking for here is 8/12. For the other one, I can see that I now have both top numbers. So that's where I'm going to focus. How do I get from 25 to 5? Since it's getting smaller, I'm going to have to divide. But by what? 25 divided by what makes 5? Well, it'd be 25 divided by 5. So I'm going to write a divided by 5 right here. And again, whatever I do to one side of the fraction, I have to do to the other. So 30 divided by 5 will give me the missing number, which is 6. For more math tutorials like this, or for the 1-minute version of this skill, click the links that you see on the screen here. Until next time, I'm Mr. D. Thanks for joining me.